Lab 1 Charge Tape by Alexander Koke. Introduction. The objective of this lab was to prepare two clear pieces of tape, investigate the behavior of electrostatic interactions between the tapes and other objects, and 3. To determine the excess amount of charge on the tape and electrons transferred. For the main lab results from this experiment, it was discovered that 1. The tapes repelled from each other, 2. Charged tape had an approximate net excess charge of 1.31 times 10 to the negative 8 coulombs, and 3, equivalent to a tape difference of 8.16 times 10 to the 10th electrons. Models and principles. There were two main physics ideas that were used in this experiment. The first one being Newton's second law, using force equals mass times acceleration, and substituting that acceleration for gravity. And the second one was Coulomb's law, which is used to find the electric force of charged particles using this equation below. Experiment. In this experiment, we made a procedure as shown below. 1. Tape A was ripped off from tape B, which made it gain or lose electrons. 2. Tape A was tested to determine if it was electrically charged, bringing objects near it, such as the pen and the textbooks. And 3. Tape A was placed under tape B, where displacement was measured due to the tapes repelling each other. As you can see on the right hand side, there's a visualization. And the conditions were measured. The tape length, which equaled 0.25 meters, tape width 0.020 meters, mass 2.5 times 10 to the negative 4 kilograms, and the separation distance 0.025 meters. Along with this, we discovered the systems and surroundings, the system being tape B and the surroundings being tape A and all the other objects around, including the Earth. In addition to the experiment, we also made some observations, which was that the tape was attracted to my hand in a negatively charged pen, and that the tape B was positively charged, meaning there was a loss of electrons once ripped away from tape A. Some calculations that we made were the area of the atom, which was 1 times 10 to the negative 20th meters squared, the number of atoms, which was 5.0 times 10 to the 17th, the force was simply mass times acceleration, which equaled negative 0.0025. Q, using Coulomb's law, equaled 1.31 times 10 to the negative 8 coulombs. And the number of electrons using this equation below, which equaled 8.16 times 10 to the 10th electrons. Furthermore, I created a code in GlowScript indicating my constants. And using these constants, I created calculations in order to print out the electric force, the charge on the tape, the number of atoms on the tape, and the number of electrons lost. As you can see on the left hand side, this is a product of my code, which shows the 2 points and the 2 vectors going up and down, which are equal magnitude but opposite in direction. And using this, I found the electric force magnitude, which was 2.5 times 10 to the negative 3 newtons, and the charge of the tape, which was 1.31 times 10 to the negative 8 coulombs. Similarities and differences. Some similarities that I found in this experiment was that the force of gravity and electric force were equal in magnitude but opposite in direction. The calculations for electric force and charge were the same, indicating Coulomb's law, and like charges repel and opposites attract. The differences were that the tape was modeled as a point in the code, but in reality, the charge may be uneven. The second was that the measured forces were weaker than the predictions. What if electrons had positive charge and protons had a negative charge? Well, gaining electrons would make the tape positive, losing electrons would make it negative. Light charges would still repel, opposite charges would attract. Tape A and tape B would still repel. Same attractions and repulsions would still be observed, but the label of which tape is positive or negative would change. Why? Why is it important to handle the charged tape as little as possible? Well, because the skin and the air near it are tightly conductive, so when the tape touches your hands, charges can transfer between the tape and your body, thus neutralizing the tape, reducing the charge imbalance, and no longer have repelling or attract as strongly. Holding it for too long can allow humidity or oils on your skin to drain the charge away as well. In conclusion, through observation, we can determine if an object is negatively or positively charged by observing its interaction with tape, using Coulomb's law to estimate the charge in an object, and discovering the charge, we can calculate the number of electrons lost or gained. Some potential sources of error in this experiment was the negligence of air resistance, the humidity, the excess contact between the tape in my hand, as well as the oil from my hand.